Okay, in this one we'll be learning what tangents to a circle. Okay, so this is the problem. Given that AT or TA and TB, which is there at the bottom, are tangents to a circle with center O, given that ATB, calculate angles X. Here's X. This is supposed to have been X. Let's put here X, Y, and Z. Okay, so that's what we will be calculating in this problem here. So we need to start with what we are being asked to do first, and then we go to the second one and then the third one in that order. Okay, so let's start. The diagram may not be visible because I need to be showing the working. All right, so okay, so let me do this. As I have this diagram here, I'm going to start A. Okay, so picture the diagram, as the diagram will be visible to you guys also at the same time. So we're going to start. So we look at this thing here, A, T, B. Okay, this is an isosceles triangle. So this length will, let me use red for the working. This length will be equal to this length. Okay, so we know that for a fact. So what do we know about this now? So let's start. We're gonna put here, consider triangle A T B. That's the triangle we're gonna be working with. All right, and we're gonna say now that angle T A B is equals to angle A B T, which we are calling X. All right, these are the base angles of isosceles triangle. Okay, so that's the isosceles triangle that we have. Okay, so we need to recall that the isosceles triangle would then have base angles which are equal, so these two would be equal, but remember they are on the side this way. So but that is okay still yet. So now we have that so angle TAB equal plus, sorry about that, TAB plus ABT equals, plus again, sorry about that, plus BTA. All of them are angles. Let me put the angle sign here, or you can go at the top with the middle letter with the little symbol as angles, 180 degrees. Sum of angles of a triangle. That's the reason for it. Okay, now since we know that TAB, and TBA or ABT are all equal to X, here we can input the information that we have. So we put here X plus BTA BTA equals to 60 degrees equals 180 degrees. Okay, so that's what we have there. Now we substitute, we do our evaluation, we get 2x plus 60 degrees equals 180 degrees. 2x equals 180 degrees, take away 60 degrees. 2x equals then 120 degrees. All right, so x is equals to 120 divided by 2, which gives us 60 degrees. So this is the value for x. Okay, so we just solved the first one. So this is to 60 degrees, right? So let's go now to B. Now let me just go review this over again. This, from the looks of it, is an isosceles triangle. Okay, they have to be equal lengths because there's a tangent here. All right, so therefore what we do, we label both of them the same letter because they are the base angles, they must be equal. And since this is 60 degrees, we can say a total angle in the triangle is equal to 180 degrees, which we did here. Now since we have substituted, we solve for the unknown and we get that the angle we are looking for is equal to 60 degrees. So we have that. So now what we do now is go to the second part. which is the angle y. Okay, so the way we're going to work with b now is as follows. We put b here. We're going to say now that OAT, angle OAT is equals to angle OBT, which is equals to 90 degrees. Why is that? Angles between radii and tangents, because we know that there's a tangent, we said it from the beginning. Okay, so we can say now, what is it that we have? What is it are we looking for? We can say that now OAT is equals to OAB plus TAB equals to 90 degrees. But we have angle TTBA or BAT. Alright, so we can substitute for that one there, so we can put our value into our problem. So we get here 60 degrees plus what we want here, which is y, plus that equals 90 degrees. So y equals 90 minus 60 degrees, so y is equals to 30 degrees. So that's what we get for y. Okay, basic substitution. So let's go over it again. We know that the angles must equal to 90 degrees because they are these two here. This length OA and OB are the radii of the same circle meeting the line which is a tangent at a point, a contact point, so that's a 90 degrees. So this must be 90 degrees here. Okay, since we have the value of the inside angle here, we can say that this angle plus this angle must equal to 90, and since we have one, we can substitute into our equation and we solve for the unknown. Okay, which we got there. Now that was one method that we could have done, all right, for finding b. Okay, so we got that one there for b. So now we're going to go to z now. Okay, so let me go to z. I wonder if it could fit here. Let's see if we could c could fit here. So we're going to say now, consider triangle AOB. So this is what we are going to consider now, AOB, this triangle. We already know what's the value of y. We know that this radii must be equal. We know that this must also equal to y because they are the base angles of an isosceles triangle. So we're going to work with that. So we're going to say now that angle OAB equals angle OBA, which is equals to y, which is equals to 30 degrees. This is the base angles of isosceles triangle. We can say that. So OAB, the angle OAB plus ABO plus BOA must equals to 180 degrees. Sum of angles of a triangle equals 180 degrees. So we put here 30 plus 30 plus z equals 180. 60 plus z equals 180 degrees. So z, angle z, must equals 180 degrees minus 60, which is equals 120 degrees. So that's what we get for c. Okay, that's one method. Or for this one here, since you already have, depending what you want to do, since you already have this angle, you can say that this angle plus this angle must equal 180 degrees. We can work that out. So our next method for us to solve C would be as follows. or let me put here, or you can put that ATB plus AOB equals 180. Opposite angles are supplementary. You can say that. So therefore you can put here 60 plus AOB equals 180. AOB equals 180. Take away 120 degrees. AOB equals then we have here what? Sorry about that. This is supposed to have been 60. So you have here 120 degrees for AOB and AOB, which is Z. So you notice we can work to more than one method, so don't stay only to one method. Math is, the beauty about math is that you can work the problems in more than one method compared to just other things that you can just solve them one method. This is depending what theorem or what or how you see the problem. All right, so you could have worked this one here first and then go to y and then go to z to x. It depends on how you want to work with the problem.